This is part 2 of the video on container-to-container and pod-to-pod networking. First, let's discuss the virtual bridge. So the virtual bridge is a key component of Kubernetes networking and is implemented as a software-based switch, often using the Linux bridge. And it exists in the root network namespace on the host node and is responsible for forwarding traffic between virtual Ethernet or veth pairs to facilitate pod-to-pod communication. And this enables pods on the same node to communicate as though they are on the same physical network, even though they operate in isolated network namespaces. The traffic flow through the virtual bridge can be explained in more detail. So step 1 would be traffic initiation. So the traffic originates from eth0 inside pod 1, and every pod in Kubernetes has its own network namespace, which includes an Ethernet interface, or eth0. And when container 1 or container 2 in pod 1 sends a network request, it leaves eth0 and enters veth0, the virtual Ethernet pair that connects the pod's network namespace to the node's root network namespace. And then step 2 is the virtual bridge routing. So once the traffic enters veth0, it traverses into the root network namespace of the node. And here the virtual bridge behaves similarly to a physical Ethernet switch. So it inspects the packet's destination IP address and determines whether the packet needs to be forwarded to another pod on the same node or somewhere else. And the bridge maintains a forwarding table, much like a switch would do in a physical network. And then step 3 is traffic forwarding. So the virtual bridge decides to forward the traffic to veth1, the counterpart virtual Ethernet interface that connects to pod 2. And the bridge sends the traffic out on veth1, facilitating the communication between pod 1 and pod 2. And the final step is step 4, traffic reception. So the traffic flows into eth0 in pod 2, and from here container 3 in pod 2 can receive the traffic as if it had originated from a remote machine on the same network. And this completes the communication path between pod 1 and pod 2. So in essence, this virtual bridge allows for pod-to-pod communication on the same node without the need for an external network interface or routing. And so let's discuss in more detail container communication. So Kubernetes supports both intra-pod, so within a pod, and inter-pod, so between different pods. In this case, between pod 1 and pod 2 communication. And this relies on different networking concepts. So first, let's talk about intra-pod communication, or within a pod. So inside a pod, multiple containers can communicate over the localhost interface, for example, 127.0.0.1, and this is because all containers in a pod share the same network namespace. So for instance, container 1 can send a request to container 2 inside pod 1 via 127.0.0.1, and both containers will perceive it as a local communication. This is because they share the same IP address assigned to the pod and the same eth0 interface. So this local communication is efficient since it avoids leaving the pod's namespace or passing through the node's network stack. Next, we have inter-pod communication. So pods communicate over the network as though they were separate machines, and each pod is assigned a unique IP address and operates in its own network namespace with its own eth0 interface. And in Kubernetes, all pods are assigned IP addresses within a flat network space, meaning they can communicate directly with one another without NAT, or network address translation. And this diagram highlights how traffic flows between the pods. For example, pod 1 and pod 2 communicate through their respective veth interfaces and the virtual bridge. The packet leaves pod 1's ETH interface, traverses the virtual bridge via the veth pair, and then arrives at pod 2's ETH0 interface. And Kubernetes uses the CNI, or Container Network Interface plugins, to ensure that inter-pod communication works across nodes by extending routing and bridging across the entire cluster. However, this diagram specifically focuses on intra-node communication, where the virtual bridge facilitates pod-to-pod communication on the same node. And finally, let's talk about the role of the node's network interface, or ETH0. So while pod-to-pod communication within the same node is handled through the virtual bridge, the node's physical or virtual network interface, often labeled as ETH0, as in this case, plays a crucial role in the node's communication with the external world or with other nodes in the cluster. So the node's ETH0 is used for external traffic. And you can see here, the node's ETH0 interface, which is located inside the root network namespace, is responsible for communicating with other nodes, services, or external clients outside the Kubernetes cluster. And this interface might handle inbound traffic from external users via an ingress controller, or traffic destined for services running on other nodes in the cluster. And when external traffic needs to reach a pod, for example, through a service or ingress, it will often enter the node using this ETH0 interface before being routed to the appropriate pod via the service's virtual IP and the virtual bridge. And in terms of intra-node communication, so for pod-to-pod communication within the same node, as depicted in this diagram, the node's ETH0 interface does not directly get involved. So instead, the traffic is routed internally within the node through the virtual bridge, and it bypasses the physical interface altogether. And this internal routing mechanism is efficient and prevents unnecessary traffic from leaving the node. So once again, intra-node communication, or pod-to-pod communication, let's say pod 1 to pod 2, does not involve this node's ETH0 interface. But how about for inter-node communication? So when pods on different nodes need to communicate, the node's ETH0 interface becomes very important. So in such cases, traffic is routed out of the virtual bridge through the node's network stack, and then out via the node's ETH0 to the external network or overlay network. And on the receiving node, the process happens in reverse, with the traffic entering the ETH0 interface and being routed to the destination pod. So notice that for intranode communication, the ETH0 interface is not important and doesn't get involved at all. But between different nodes within the same cluster, the ETH0 interface is very important.